Hi, hi.
Hmm.
Time ki join kawale. You have to join at the strike of 6 o'clock sharply.
Okay,
Don't waste my time.
okay. Sorry.
So far, we are studying what the important fundamental Olympiad chemistry
Foundation.
topics.
Hmm.
So far, we have discussed. I explained what is
Chemistry.
chemistry,
What is
what is compound, what
compound?
is
What
molecule,
is molecule?
and what
What
is
is
an element.
element? What is
Today,
element?
today I would like to explain. Today I would like to explain. Today I would like to explain atom concept. Okay, atom
Okay.
concept. Listen carefully. According to Dalton atomic theory, according to scientist Dalton atomic theory, what he said in his theory, actually this theory was proposed in the year of 1806, 1803.
Hmm.
1803, Dalton proposed atomic theory. So
Okay.
according to Dalton scientist,
Okay.
atom is the smallest part of the matter. Atom is
Hmm.
the smallest part of the matter. It is invisible and it is indivisible.
Indivisible.
It is invisible and indivisible.
Indivisible.
But modern theories suggest that atom is a smallest particle. No doubt, atom is a smallest particle, but
Hmm.
it is visible and divisible. It is visible
Divisible.
and divisible. So there is a possible to see uh, atom with our eye by using special microscopes. Okay. So modern theories suggest that atom is a visible to our eye by
To our
using
right.
some special
Items.
special
Micro.
microscope
Microscopes.
special listen carefully, and also it is divisible. That means there is a possible to divide the atoms into smaller one. So modern theory suggests that what the modern theory suggests, atom is having some subatomic particles in inner core of its structure. In inner core of its structure, atom is having subatomic particles. What are those subatomic particles? Nothing but electron, proton, neutron.
Neutron.
Electron, proton, neutron.
No.
So, as per new atomic models, these electrons, protons, neutrons, subatomic particles are nothing but fundamental particles. Those are called what? Fundamental
Fundamental.
particles. Fundamental particles. So here theories explained about fundamental particles and their orientation also explained by modern theories like Rutherford atomic model, Bohr atomic model, Sommerfeld atomic model. Like that, we have advanced theories to understand the inner core structure of atoms.
Atom.
At your 8th standard, at your knowledge, you have to remember some important things. What is that? Electrons means, simply remember, electrons means negative particle. Electrons
Hmm.
means
Negative
negative
part.
particle.
Proton means
Electron,
plus.
electron means negative particle. That means it carries negative charge.
Hmm.
Negative charged particle is called electron. Okay, you remember
Electron.
that.
Hmm.
The relative charge that is represented like this, E minus 1. Electron is represented like this, E minus 1. And its relative charge represented with minus 1. Represented
Minus.
with minus 1.
Minus.
And electrons were discovered by scientist J.J. Thomson. Who
J.J.
discovered
Thomson.
electrons? Who discovered electrons?
J.J. Thomson.
Scientist J.J. Thomson discovered electrons
Electrons.
by doing what is that silent electric discharge tube experiments. Okay, so at this stage you should remember simply electron means negative charged particle, electron means negative charged particle. It is bearing what? -1 charge. The relative charge of electron is -1. Electron was discovered by famous scientist J.J. Thomson. And moreover, electrons are present around the nucleus.
Okay.
In an orbit like this. For example, this is an atomic structure. You know, electron means negative particle. This negative particle revolving around the nucleus in a circular path. These are called orbits. These are called orbits or cells. These are called orbits or cells. These are called orbits or cells. Okay. Then second subatomic particle, that is proton. So proton means simply remember positive charged particle.
Yes, positive charged particle.
Positive charged particle. Particle is called proton. It's symbolized. It is symbolized with P plus. It is shown as P plus. It is shown as P plus. Its relative charge is +1 unit. Its relative charge is +1 unit.
+1 unit.
Proton was discovered by scientist Goldstein.
Goldstein. Pani dabda anukuna.
Goldstein discovered proton. So see, once again I will tell you. Try to understand. Electron means negative charged particle, which is bearing -1 unit charge. Electron is symbolized with E minus. It was discovered by scientist J.J. Thomson. When we come to another subatomic particle, that is proton. It is positive charged particle. It is symbolized with P plus. It is shown as P plus. The relative charge of proton is +1.
It is discovered
Relative charge of proton +1. Proton was discovered by scientist Goldstein. Then another subatomic particle, that is neutron. So neutron means neutral charged particle. Neutron in the sense neutral charged particle. Neutral charged particle. So neutral charged
it has no charge. It has no any charge.
Very good, nice. Neutral charged particles means neutrons do not have any charge. It has no charge. Okay, it has no charge. That's why neutron symbolized with Z0. It is represented like this. N0. Okay. So when we have an idea about electron, proton, neutron. Okay. So simply electron means negative particle, proton means positive particle, neutron means zero particle. That means it has no charge. Okay. Electron is discovered by scientist Thomson. Proton is discovered by scientist Goldstein. Neutron is discovered by scientist Chadwick. Okay. See, when we have idea about these fundamental particles, subatomic particles, then we go to understand something about structure. See, so for example, the center part of atom, the concentrated center part of atom is called nucleus. Nucleus contains protons, P plus, and also neutron. Nucleus contains protons, positive particles,
Neutron also positive.
Neutron is a neutral particle.
Okay, neutral particle.
It has no charge. That's why I represented N0. N0 means no charge. P plus
Okay.
means positive charge.
Positive.
Okay. Do you understand this?
Understand.
That means simply what is that? Protons and neutrons, subatomic particles which are present in the nucleus. Which are present in the nucleus.
Nucleus.
These electrons plus these protons plus neutrons collectively called as nucleons.
Nucleons.
Collectively called as nucleons.
Nucleons.
So nucleons means the combination of the sum of protons and neutrons which are present in the nucleus.
Nucleus.
Okay. So around this nucleus, electrons are revolving. Electrons are revolving around the nucleus in a circular path. These circular paths are called what? Energy levels. Energy levels.
Energy
And
levels.
also called orbits. Yeah, and also called orbits. And also called what is the cells? Main cells.
Cells.
Main
Cells.
cells.
Okay.
So we use three terms. See, the circular path of electrons. The circular path of electrons are called energy levels, main energy levels, and also called orbits, and also called orbits, and also called main cells. Okay.
Main cell.
For example, different electrons rotating, circulate around the nucleus like this. All these are nothing but what? Cells.
Electrons.
The cells are represented with letter A, L, M.
A-L-M.
A-L-M.
Okay, A-L-M.
K-L-M.
K-L-M, okay.
Okay, so try to understand one more time. I would explain one more time. Listen carefully.
Okay.
So far, what I am saying, electron means negative charged particle. Negative charged particle discovered by scientist Thomson. Proton means positive particle discovered by scientist Goldstein. Neutron means neutral particle. It has no charge discovered by scientist Chadwick. These three are subatomic particles or fundamental particles present inside the atom, particularly neutrons and protons present in the nucleus. These protons, sum of protons and neutrons, collectively called as nucleons. This word you have to remember. Nucleons means what is nucleons? Nucleons means sum of protons and neutrons.
Combination of proton and neutrons.
Okay. So around the nucleus, actually the net charge of nucleus is positive charge. This net charge is nothing but positive charge. You know, it is atom. In atom, it is center. There is a positive charge. So due to positive charge, what happens in the inner core of atom is the negative charged particles, electrons, revolving around the nucleus. Around the nucleus as a circular path. These circular paths we call as energy levels and also call as orbits and also call as main cells.
Main cells.
Those main cells are represented capital English letters K, L, M, N. K, L, M, N and so on.
Okay.
K, L, M, N and so on. Okay. Is there any doubt about this?
No, nothing.
No doubt. Nothing.
No doubt. Nothing.
Have you understood? Have you understood?
Understood.
Okay. So here what happens? I tell you one important thing. Please you remember. I tell you one important thing. What is that? You know already electrons electrons E minus, protons P plus, neutrons. All these are nothing but subatomic particles and fully unstable, highly unstable, highly unstable. Actually, these subatomic particles present in inner core of the atom. Actually, these atoms, these particles, we can't see with our eye. Even by using advanced technical missions, we cannot possible to see these subatomic particles. Why we can't see? Why we can't observe?
Because they are
Because
not
those are
stable.
highly unstable.
They are unstable.
These are subatomic particles are highly unstable. Okay, highly unstable. Here, what happens due to its instability? These atomic particles, electrons, protons, neutrons, undergo some cohesive forces. Together, they can undergo some cohesive forces and converted into atoms. These are least stable. Okay, least stable.
Okay.
Even atoms also trying to attain the stability. They can undergo chemical change, transform into molecules. That means unstable subatomic particles undergo cohesive force together to form least stable atoms. Even atoms are also unstable. For attaining extra stability, what happens? Atoms themselves undergo chemical change, converted into molecules. These are stable. Molecules are stable. You know, molecules are stable. Again, molecules undergo chemical change to give compounds. Actually, these are more stable. So try to understand. Lucky, what I am telling here, these highly unstable subatomic particles like electron, proton, and neutron together undergo cohesive force, converted into least stable atoms. Even at this stage, atoms are also unstable. For attaining extra stability, these atoms themselves undergo chemical change to form molecules. These molecules are somewhat stable. Again, molecules undergo some chemical changes. Finally, they have to form stable compounds. Here, from this, what we can understand, the reaction, the chemical change, move from instability to stability direction. You know, these chemical changes, or whatever the change in nature, or whatever the change in chemistry, whatever the change in physics, even come to social change, whatever the change, always occurs or move from instability direction to stability direction. Okay, so here what happens? Subatomic particles on change, on change gives atoms. Again, atoms on change gives molecule. Again, molecules on change gives compound. So the change of transformation of instability to stability matter. The study of instability to stability in chemical towards chemical reaction. In view of chemical reaction, we are studying instability to stability change. That is called chemistry, you know. So these things you have to remember. These are the important things today we discussed. Tomorrow I give you notes. Let us stop here. So regarding this, is there any doubt? Regarding this, is there any doubt? Huh? No. Everything you understood?
Understood. Daddy.
Good, very good. Good. Okay, let I stop here. Remaining part will continue in the next class. Okay.
Okay. 1 minute. Adi raskunta kindidi.
I give you notes tomorrow clearly.
Okay. Tomorrow
I give you. Huh? You don't worry.
Okay. Bye, Daddy.
Bye.